Hey yo everyone, and welcome back to 5 Block Fridays. This week we are making Conway's Game of Life in Minecraft using just 5 command blocks. You probably already know what Conway's Game of Life is. There's plenty of videos. I have an older video of mine that is a data pack that does Conway's Game of Life, but this one is just 5 commands. For context, my previous video, the data pack for that, had about 110 commands in the entire thing. So for this simulation, just like last week, this stack of command blocks runs a single tick of the simulation, and we have armor stands. This week we're naming them Conway, of course. These armor stands are where all the commands get executed, so they kind of define the boundaries of what is happening with this implementation of Game of Life. So yeah, Game of Life, you have a grid of cells that can either be alive or dead. We're using white caps to show cells that are alive and black caps to show cells that are dead. If a living cell has 2 or 3 neighbors, it stays alive. If it has fewer or less or more than that, it dies the next generation. And if a black cell has exactly 3 neighbors, it will come to life the next generation. So here's just a really simple oscillator. These two right here in the center will go back and forth between being alive and dead every generation. So we run it once, now they're dead. Run it again, now they're alive again. And we can set this to be a repeating block, and they flicker back and forth really fast. Yeah, so that is really straightforward demo. I'm going to go through each of the commands, and I have a much larger demo set up at the end. So yeah, here's how the commands work. This first command block takes care of counting all the living neighbors around each armor stand. So we're executing as entities named Conway. We're executing at their position. This store here says we're going to take whatever comes after it, and we're going to store the result in entity data. The entity we're modifying is the current entity, and the location that we're modifying is ArmorItems 3, so the helmet slot, in its tag section, and we're creating a new custom tag called neighbors. And whatever we get is going to be stored as a byte, and it's going to be scaled by 1. Then in this if statement, and if statements, if they're using store, will return the number of matches it gets. So if entity at e will return however many entities match this target selector. So if entity at e named Conway between 0.5 and 1.5 blocks, so we're looking for other armor stands, and then this NBT check goes into that armor stand's helmet slot and checks under the tag section, under display, and checks if the color is 163839998. This isn't a random value, this is the value that a helmet gets when it's dyed with white dye. So overall, what this is doing is counting the number of living neighbors in the 8 blocks around an armor stand, and modifying that armor stand's helmet to keep track of how many living neighbors it has. The second command takes care of finding dead cells that have exactly 3 living neighbors and bringing them to life. So we execute as entities named Conway, we go into their NBT data and check if their helmet slot has a color of 1908001. This will match helmets that have been dyed with black dye. Then we execute if the current entity, again going into its helmet slot, has the neighbors tag set to 3. So this will match entities that in the previous command block had exactly 3 neighbors. In our run statement, we're using data merge to modify this entity's data. The first thing we're doing is going into its armor items and setting its helmet to be still a leather helmet, but with a color of 163839998, so the white helmet. We're setting that helmet to already have neighbors set to 3, This will keep it from being killed in the next round. And we do a bunch of other modifications to the armor stand. So we make it invisible, we turn it into a marker, and we fix its rotation and pose. These just all work together to make them more uniform and to make them more efficient, especially the invisible and marker makes things a lot more efficient on rendering when you have thousands of these armor stands. This third command block is practically identical to the second. We've just swapped every instance of a white helmet with a black helmet and vice versa. And then in this execute statement, instead of saying if the current entity has exactly 3 neighbors, we say unless the current entity has 2 neighbors and unless the entity has 3 neighbors. So we stay the same if we have 2 or 3 neighbors, and if we don't, then we go into the run statement and swap the color of the helmet on the current armor stand. This fourth command is really straightforward compared to the previous 3. We're executing as entities named Conway. We check if their helmet is the color of a black helmet, and if so, at their position, we check if the block beneath them is white concrete, and if so, we set the block beneath them to black concrete. And again, the fifth command block is practically identical to the one before it. We've just swapped the color for the color of white helmets. We check if the block beneath us is black concrete, and if so, we set the block beneath us to white concrete. So, as you may have guessed from those commands, this isn't really the most efficient implementation of Conway's Game of Life. It's probably the most compact that's been done in Minecraft, at least that I've seen. So yeah, here I have an area set up with a much larger simulation just to show a bit more of a stress test of what can be done. Let's see, I have a map here of the area. So yeah, there are about 1,000 armor stands here, and I've done a lot of optimizing, narrowed it down so only areas that actually have stuff happening have armor stands. If I wanted to do something that was, there's a lot of things in Game of Life that can grow infinitely or keep doing stuff. I'd have to have armor stands everywhere, and you can already sort of see the legs starting and the commands aren't even running. So yeah, it's a bit of a stretch even doing this. So let's set this one to be a repeat and turn it on and watch what happens. You can already see it's going a whole lot slower than that tiny little demo back in the bunker. But yeah, we have Conway's Game of Life. We have an oscillator here that has a period of 3. These 3 oscillators here are much longer. It takes 15 ticks to get back to the start. And then we have a little glider gun right here. That's just creating gliders, sending them out. They behave a bit weirdly because they reach an edge, and Game of Life doesn't normally have an edge. So they just turn into little blocks and then destroy each other eventually. So yeah, that is Conway's Game of Life in Minecraft. If you want to see a much more efficient version, check out my older video with the data pack. I might do another video soon just going over how that works. I think that one's pretty clever with how it efficiently uses armor stands and is creating new armor stands and destroying them to make sure it can keep going. But yeah, that is pretty much it for this video. I hope you enjoyed, and I hope to see you all next week.